In this video, let us discuss network delay time. The given problem is you are given network of n nodes labeled from 1 to n, and you're also given the times a list of time travels as directed edges times of I, that is ui, vi, wi, where ui is the source node and vi is the target node and wi is the time for the signal to travel from source to target. We need to find, we'll send a signal from the any given node k. The k is here the given node, and we need to find minimum time it takes for all the n nodes to receive the signal. Here if you observe, it is a given from it is a directed graph from the 2 to 1 we can go by the time 1, and 2 to 3 it is 1, and 3 to 4 it is 1. So here the catch is we need to find the shortest distance. If you observe here, from the 2 to it will go to the 1 node, and from the 2 it will go to the 3, and from the 3 it will go to the 4 through the time 1. So we can solve it by using Dijkstra algorithm. Before that we need to represent adjacency list. So we can represent by the list adjacency list, where we should connect with the source list of and then list of the integer array, like the 1 is connected to empty, and 2 is connected to 3 with the weight 1, and 2 is connected to 1 with the weight 1, and 3 is connected to the 4 with the weight 1, and 4 is connected to nothing. So it is like list of 0, list of 1, list of 2, where here the 0 1 toward the source, and the destinations is like with along with the weights will add. So that's why it is a, list of the integers. So suppose if you take any simple example, like here it is the source, and it is these are all are the nodes, and the from source to destination here we can go to like 5 time or 1. And then suppose if you want to move from this nodes to this node, we can move from here to here like the 8 time, but you can see we can also go do this path. So for that it can be 7. So 7 comma 8 we should take 7. That's why we will take here a priority queue. The priority queue, what we are doing is like every time we'll take the shortest distance. Like if source is here, if you want to traverse, then instead of we can take the choice 5, 3 and 8, but we can take the 3 because 3 is the shortest. And like because we are storing in the integer array, the second element is the time, right? So we are sorting, custom sorting. So then we are filling the first we're filling the maximum value. Like suppose this is the source we need to traverse all the nodes. So for that we need to go to all the nodes, right? For that first we will initialize everything is infinity. The starting itself it will be 0, then the 0 to, if you want to go from here to here, let us think for that. So we need to add that new int of integer of k. Then we added this source with with the distance as 0, and itself is 0, right? So that's why then the source something, yes, I'm representing with the alphabets. Then we are taking boolean. It is same as like the bfs part. We will take the node, we will add in the queue, then we will explore the nodes, and then we'll check if it's visited or not, or then we'll add to the queue. So then kindly check the problem, find the path if they exist or not, that problem. So it is that on top of it is the Dijkstra algorithm we can use to find the weighted graphs. So we'll add in the Dijkstra algorithm. Then so when we are polling, so for the at the first we added this s comma s comma 0. So then we are checking s comma 0, that from here we need to check, we need to explore. So for the s, that is 0 0 is nothing to nothing, but here the 0 is connected to some 3 nodes, right? So we can go to any one of the nodes. So but we can go to this node because of the priority queue. We can get this, like suppose if it is b, then it is a b comma 3. From here again we can choose, we'll add this. We are exploring this one. So after we added a b, then we can check other nodes. So it is we'll store 5 here in the distance array, we will store it. Suppose after exploring this node, if we take the some other node like 8, so for the 8 also we can reach c. it will update 8, but instead of 8 will update the older value. That's why we wrote the logic here. If the new distance is a less than distance of next node, then we'll update the that latest node. So this is a brief introduction about this problem. Please kindly check the code written here.